Hey everyone, I'm Nicholas. I'm here on behalf of the Data Science Club at the University of Waterloo. So just a quick Data Science Club plug. Basically, we're a club as a part of MathSoc, and we run a bunch of workshops, events, etc. We have like a resume critique coming up and co-op panel, so it's like a great club to be involved in if you want to learn about data science, get co-ops in data science, etc. So please check out our Facebook page, come by our office whenever. Our door's always open, and we love to chat. And also my contact information is there. So if after the workshop you have any questions or you want to reach out, please feel free. I'll also be here all of tomorrow as a mentor. And yeah, the links at the top, bit.ly/intro to pandas is the completed workshop notebook on my GitHub, so you can check that out. And the second link is like a full example of working with this data set and using pandas, so you can just see a good example. Any questions before we start? Cool. So what is Pandas? Pandas is basically a library in Python that allows you to analyze data frames and basically manipulate like tabular data. And by tabular data, I basically mean like a data that looks like a spreadsheet. And so you can get started with that by literally importing Pandas as PD, first step. And hopefully that'll work. Oh, I lied. I need to connect to Wi-Fi. Whilst that's happening, I can tell you about the tool I'm using. I'm using a tool called Google Colab. So Collab is basically a notebook that runs in your browser that lets you run Python code. It's super convenient, super useful. All your plots will show up in line. You can run code and the state will be persistent. You'll see throughout this workshop why this is super helpful. But yeah, cool. First thing we're going to do is import pandas as PD. Yep.
How is the Google Colab different from the Jupyter Notebook?
Good question. So Jupyter and Collab are basically the same thing. This is just Jupyter Notebooks that's hosted by Google. What's really nice about Collab is you get some more compute power in the backend. So actually, if you go to the runtime, and if you not manage sessions, that's not what I want to do. Change runtime type. Oh. You can actually get like a GPU or a TPU backend. So if you're doing any kind of like machine learning, it's like super great, and you can get some acceleration for free. Yep. No, that's the great part. So you can use a GPU completely for free for 12 hours a day. It's not super powerful, but it's like much better than nothing. So it's like a great resource. Anything else? Cool. So let's get started with some Jupyter tips first. So one tip is, so if you have a little question mark in front of your command and you enter that, you can actually see like the signature of the function you're using, which is super helpful with all the documentation. And if you use two question marks, you can actually see the code used to implement the function. So it's a really great way to explore the libraries that you love to use and like understand how things work under the hood. And so we'll start out with like the basic unit of pandas, which is something called a series. And so I will just create a series right now. Hold on. Cool. So this is a panda series. This basically works exactly the same as a normal array, as you'd expect, but there are some key differences. So this is much faster than a Python list or array because it's actually implemented in C in the backend. So it's very quick. It's very similar to using a NumPy array if you've ever used that library before. And you can do all the basic things you'd want to do with an array. So for example, you can index into it as normal. You can do stuff like strided, like range indexing. So this is like accessing the first three elements. Like you can do stuff like accessing every second element, just like you would in Python. If you're not familiar with these features, I encourage you to play around with it. And you can also do cool things like take a random sample from this series. And so this is a random number, like a random selection from the series. If you'll notice here, this second column is the actual data that's in my series. This first column is the index. And so for example, if I want the number 1, I'm going to type in 0, which is the index. That'll give me 1. The last thing to notice is that every series has a data type. So for example here, this is a series of integers, and so it's int64. If you have a series of strings, it'll be object. There are other types as well. Cool. So before we move forward, any questions about series? No? Cool. The last thing I want to show you about series is something called broadcasting. So could you raise your hand if you're familiar with broadcasting? Great, perfect. So what broadcasting, this talk is not going to go into detail about what it is, but this is like super important for any kind of data processing or numeric computation you want to do. Essentially, I think it's easier explained than, shown than explained. So I'm going to make a new series, and this time I'm going to make it from if I can type, from a Python list for I in range 10. So S2 is just a series with a list that, let me do like +2 just so it's clear. So as you can see, Jupyter's super cool. You can change things like that, and it's very convenient. So this is just a series made from a list, and you can do stuff like this. S2 divided by. And so here, I'm dividing this entire array or series by a single value, like a scalar. And it applies this to every element in the array. And so this is very efficient, much more efficient than looping over things. And it's super convenient. And so you can also do stuff like, divide by 2 and add 1. And it divides all the elements by 2 and adds 1. This is like a super basic version of broadcasting. If you're interested, I'd encourage you to Google that. Broadcasting. And so yeah. Any questions about what I just did? No? Cool. So let's get started with data frames. Data. So you just saw a series, which is a one-dimensional array containing whatever information you want. A data frame is basically like a two-dimensional array that contains your data. And so I will actually import some data, and I will copy and paste because I am lazy. Cool. So what did I just do here? Pandas has a function called readCSV, and essentially this reads a comma-separated values file. If you don't know what that is, I encourage you to Google it. It's basically like an Excel spreadsheet kind of. And this is from like a CSV that's hosted on GitHub. And this is Pokemon data. And so this is how that data frame looks. So a little bit of background. This Pokemon data is some data that I scraped off the web for a little project I did. If you want to check it out, you can just check out one of the 2 links that I posted earlier in this workshop. Essentially, it has information about Pokemon stats, its moves, its name, its types, etc., etc. And so this is the data set that we will be working with as we go. And so just some properties about this data frame you're looking at. Right here is the index. This is the same as the index I was talking about for series. Here are the columns of your data set. And this is all the information. Yeah, nothing more to say. And as basically most of the functions you have with series, you also have with data frames. And so here, I'm just taking a random element from my data frame. Any questions about anything I just said? Cool, great. So whenever I import a data set, the first thing I do is always look at a random sample of the data, just to make sure that it looks kind of sane and what I want. You can also check how long the data set is, which is important. This is 918. I think I scraped this like 2 years ago, so whatever Pokemon was happening then, I don't know. My Pokemon days were like Diamond, Pearl, Platinum, so I have no idea how the new Pokemon work at all. Anyway, so you can look at the length of the data set. You saw the head function I used, which pulls up the first 5 elements. There's also a tail function, shows you the last 5 elements. These are just great ways to take a look at your data. Cool, now that we've imported our data, we're going to do some initial processing. So this is a data science workshop, and I would say that data cleaning / wrangling is the most important part of like a data scientist's work. And so data cleaning or wrangling basically takes the raw data that you have, you do analysis, you understand what the flaws in the data are, what issues there are, and you transform it into a form that A, you can work with, and B, is like correct. And so through this is like an iterative process, whether you have like a machine learning pipeline or some analytics pipeline, you're constantly cleaning and wrangling your data as you're producing these analyses. And so though I won't show you like the full pipeline of what like data cleaning looks like, hopefully I'll give you some skills to do that yourself and take a look at analyses online and understand what they're doing. And I also find that like being able to manipulate data like through code lets you ask better questions and understand your data better. At least for me, I tend to discard questions I don't know how to answer using the data. Like I'll keep them aside and then hopefully someone can help me out with it. But when you have more skills, you'll definitely be able to answer those questions with the data. So with that, let's start. So the first data frame I showed you has like one, so this DF data frame has one row per Pokemon. The second data frame actually has one row per move. And so let me show you that here. Yeah, so it has like a bunch of moves. Oops, there we go. So the first thing I notice here is that there is an index column, but Pandas automatically assigns an index. So let's just actually drop that column. And so you do that using the drop function. Axis equals 1. Axis equals 1 basically means that you're dropping a column. And cool. So we've dropped this column. Oh. But if you'll notice, this data frame still has the index column in it. So why is that? In Pandas, most functions will actually just return a modified version of the data set. It won't actually change the data set you're working with. And so there are two ways around this. The first way is to do this, like reassign the data frame that you're using. But what's more efficient is if you do it in place. And so that's done with the in place command here. So you just pass the in place argument equals true. And as you'll see, like nothing is returned. And we got rid of the index column. Any questions about like in place versus returning a data frame? You'll see this more as we go. Cool. I don't like capital letters in my name of my columns because that's super annoying to type. So I'm actually going to just rename all these columns, and you can do so by doing this. Columns equals name. I am not going to type all that out because I'm lazy. So it's renaming column names is as simple as getting the columns property and assigning it a list. So now we're good to go. The names are what I want. The next thing I want to take a look at is the data types that I actually have in my data frame. So that's through dtypes. And you'll find that Pandas is really good at inferring what data type each column has. So for example, if you have numbers in a column, like Pandas does a pretty good job of figuring out that those are numbers, but it doesn't always do a good job. For example, if you have missing information in your data frame, it will poop out and it'll just give you an object. An object in a majority of cases just means string, but it can usually mean like any generic Pandas object. But for today, we're just going to consider objects to be strings. And so we want to correct this. Like we can't do any numeric computation with this like object data type. We want to make sure they're integers. So for example, I know that accuracy should be an integer. But I can't convert it to an integer while there are none values. And so how I'd find that out is the following. Cool. So to break down what I just did here, accessing things dictionary style gives you the column. Actually, I can show you how that looks. So this returns a series, and the series corresponds to the entire column. And this value counts function basically counts how many occurrences of each value there are. And if you'll notice, there's this none here that we can't turn into a number. So we'll have to deal with this. And so we'll deal with it as follows. There is a replace function, and I know none is a string here. Typically, you probably want to look at one of those rows and actually, well, yeah, you typically want to look at one of those rows, make sure it's a string. I know it's a string, and because we have an hour, I'll tell you it's a string. But you basically do, you access the column you're interested in, use the replace function. You want to replace it with a 0. And remember, most Pandas functions will actually return a modified data frame. So here you want to use in place equals true. So now, when we check out this accuracy column, there are no more none values. Yeah. Does anyone see any problems with anything I just did? No? Or any questions? Yes. Yep.
So the type changed already from object to int?
Oh, wow, cool. Okay. Normally, it won't always do that, but I guess this time it did it. I was going to show you how to do that, but thanks for pointing that out. So I guess once it knows that all the items are integers, it'll do that. I don't think you should rely on that in general. I'll show you how to convert things to numbers, but yeah. Anything else? Yep. Oh, I will, at the end of the workshop, I'll just put it up on the board. But the link is, yeah, there's no Slack group. I don't know how that works, but it's like bit.ly/intro to pandas, I think. Hopefully that works. Yeah, that works. That's the link that you should be using. Anything else? Cool. So the one thing wrong with what I just did was I just blindly replaced all these none values with 0. And we didn't like stop to consider if that makes sense. So filling in like null values is like one of the hardest things in like data science and machine learning, because it's either missing data or it's intentionally none, or data's corrupted or collection. There's like some pattern in the collection that led to these values being none. You never know which one is the case, and you always want to deal with it correctly. And you never want to just blindly do what I did and just replace values with 0 because we're in an hour-long workshop. If you really think about if after a while and considering this data set, you realize that the moves that have these like none values are actually moves that always hit. And so really a more appropriate replacement would have been 100 because these moves always hit. And so these none values should have been turned to 100. I'm not going to change it here today, but it's very important to carefully consider what you're doing with your none values and like don't just resort to a default. But with like numeric data, like good defaults are like using the mean, using the median. There are like various imputation techniques. I will write that word down. You can Google it. Imputation. I hope that's how you spell it. And so I'd encourage you to Google these and look into it. Cool. Anyway, so this automatically converted the data type to numeric, like a integer. But really what you would have wanted to do is the following. So again, you access the series for the accuracy, and you do like 2 numeric of the same column, and that would guarantee that it turns it into a integer. Cool. So the next thing we're going to look at is like indexing into the data set a little bit more. So the first thing is we are going to look at, well, let me actually pull this up. Oh, the types, plural. Cool. So we also know that power should be a number, so let's deal with that, but we'll deal with it slightly differently. And the first thing I want to show you is something called Boolean indexing. So again, we're going to look at the power series, and so the power series contains a bunch of numbers indicating the power of the move. And we're going to do the following. We're going to check which of these entries are none. And so if you'll notice, this returned a series of Boolean values with true and false. And it's false where the values are not equal to none and true where they are. So just to show you what it was before. Yeah, see, like 11 was none here, and now 11 is true here. So this is super useful because now you can index into the data frame as follows. Like that. And so what this does is, since you provided a series that's the same length as the data set, which has like true or falses, this data set only contains the entries that had a true value in that Boolean index. So as you can see, all of these powers are none. Any questions about what I just did? Does that make sense? Great, cool. And so we actually want to change these to 0. So I will teach you how to index into things more properly. And so there's a dot location command, and so this basically allows you to access individual rows. And so as you saw, this like dictionary style lets you access, sorry. This one lets you access an entire column. Using dot lock will let you access individual rows. Like for example, like this is like the first move, and I will prove it to you. See here, it's karate chop, and this is the first move. And so basically what we want to do here is change all the rows that have a value of none to 0. And so we can do that as follows. So pandas is kind of confusing because there's 1,000 ways to do things, but I promise you that using .look with a Boolean index does the same thing as not having .lock. And to be completely honest with you, it probably is more clear to do it this way. So just in general, when you want to like deal with indexing a certain number of rows, use .lock. And then you can pass a second argument in to specify the column, so power. And so as you can see, these are a bunch of nuns. That was just a little bit weird. Any questions about that? Cool. So these are all nuns. We want to change these to zeros. in this case, it does make sense to change it to 0 because a move without any power does no damage. And so we will set these values to 0. Coolio, and once again, we want to change this to a numeric type. And ta-da! Now it's a number like we want. Any questions? Great. Cool. Now let's work with the other data frame. So if you remember, this data frame has 1 row per Pokemon, and we're just going to do some basic transformations on this data set. I will rename these columns too because I hate typing capitals, and I will do this here because I'm super lazy. Great, so now all the column names are lowercase. So if you see here, a bunch of these types are objects as well, but if you'll notice, some of these columns are actually Python lists, and you can actually work with Python objects within these data frames, as you see, like strings and integers, but also like lists and dictionaries. So right now, like these types and these abilities are all strings. They're not actually lists that we can use. I will prove that to you. Let's see here, 0 types. So right here, we're looking at, let me show you. So head 1 shows the first element. So here, we're looking at grass ice. This is actually a string. We want to turn this into a list. And Python has a function called eval that basically, if a string contains Python code, it will evaluate that Python code. And so now we can actually treat this like a list. And so we want to apply this eval function to each row of our data frame. Quick disclaimer, in general, you never want to eval like random Python code that you see online, or like if you download a data set, you should not be evaling things until you know it's safe. I'm doing this here because I scraped this data set myself. I know the contents exactly, but it can do like malicious things like anything that Python code can do to your computer. So any questions about what I just did? Great, cool. So we basically want to do this eval function to every row. Can someone give me a suggestion about how we do something to every row? It starts with a hint. It starts with L and rhymes with floop. I tried. It's a loop. Okay, so the first thing you think of is like doing a loop, right? I'm going to show you how to time things in Jupyter because this is super helpful. We're going to see 4 different ways to do this. One of those ways is the most efficient. And we're going to figure out which one's the most efficient by timing the code and seeing which one is like the best way to do it. So in Jupyter, there's a function that you can use to time things called timeIt. Surprise, surprise. And you can see that it's a special Jupyter function because it starts with a %sign. So any %sign functions you see in Jupyter are called magic functions. And so this will time any code that you have here. Range 50, for example. It'll run that a few times and hopefully work. Cool. So what this output means is that it ran this little bit of code, like, what is that, a million times? I think a million times. And best of 3. I have no idea what that means. Oh, it's probably, honestly, I should have probably looked at what that means. But basically, this gives you like an average time of how quickly code runs. And so this gives you an idea of how efficient code is. And another thing is you can do like a double %sign. You can like time an entire cell. So yeah, these code things I'm typing in are called cells. Now you know. So that's like the same thing. Ooh, I spelled that wrong. Cool. It'll give you useful outputs based on what happens. So any questions about the timeIt function, except for what the best of 3 means? Yeah? Yeah, good question. So the single percentage only measures the time of that one line. So the line that comes after it. The double percentage measures the entire cell. Yeah. Anything else? Cool. Great. Oh, did you?
So basically the timing is just, we want to know how fast. Okay.
The cell's running. Exactly. We're going to like do things 4 different ways and see which one's the best. And so we learn how to write pandas better. I'm going to make a temporary copy of this data frame because this timeIt function runs things multiple times. And we'll see that once you run things once, like the state will change until we can't run it again. So we'll make a copy. You'll see why in a second. Cool. So we're just going to do this the naive way, which is basically for, if you've seen a loop in Pandas, in Python, I will type this first and then explain it, I promise. Okay, so to be clear, the columns we're going to be working with are types, abilities, and moves. These three are strings that we want to convert into lists. I will type this, and then I will explain it, I promise. Okay, cool. So iteros basically gives you an index and a row. If you remember, a row is like a series, which is, like for example, a row is exactly this. And so actually, let me show you. If I have a row and it looks like this, I can actually access the elements the same way as I was for the data frame. Oh, like that. Cool. So essentially what I'm doing is getting the location. So at this index, I want to change the next evolution's like cell. And how I'm going to do that is run this like eval function I just showed you on the next evolutions, which turns the string into a list. Any questions about that? That's like a lot of code at once, like 2 lines, but does a lot of stuff. Okay, one minor tweak is I'm going to change this .lock into an @. And this is super annoying, and I promise you won't have to do this yourself in the future because I'll show you a better way. But the reason I have to change that to an @ is because when you're using .lock, you can actually access multiple columns at once. So for example, you can have a list and access 4 different elements. .at restricts you to 1 element at a time. Don't worry about details. That's not what we're worried about today. But we have to use .at here to do the assignment. Anyway, we will time this. And oh no, oh, row. Okay, there we go. It would have sucked if that was actually some real error, because I don't know how to deal with that stage. So that will run, and it takes 117 milliseconds per loop. Not bad. But I'll tell you right now, loops are rarely the best way to do things in Pandas. And so I will show you a better way. And so we'll work with now the types column. And I will type things first, and then I will explain them. Okay, actually, no, I won't explain things first. So apply is a function that operates. It basically it applies a function to your data set in some way. So for example, you can have your function here, and then if you do axis equals 1, this will apply the function to every row. And so what I can do here is, does everyone know about Lambda functions in Python? Yeah, anyone not know about Lambda functions? Cool. Just think of a Lambda function as like an inline function. So the argument here is x, and then now I'm going to do the function definition, which is 1 line. Talk to me afterward if you're not familiar with this, but yeah, I don't have much time. Cool. So basically what we're going to do is eval, actually let me name this to row. That's a more appropriate name. Eval row types. Cool. And so basically what this does is it applies this function to every row of your data frame. And I promise this will be faster, or at least I hope it will be. Let's check out how much faster this is. Cool. It's like 10x faster, or not 10x, almost like, I don't know, 6x, I guess. It's much faster. And the reason is when you call apply, there's 2 things that happens. First of all, this function is called in the C++ backend code, which is much faster than Python. And the second thing is it can do things in parallel because it doesn't have to do things sequentially like a loop. And so that's fast, but we can go even faster. And so the final way I'm going to show, well, not the final way, but the fastest way is something called a map. We're going to use that for the moves column. So once again, we're accessing moves equals temp df dot map. So I will type this out first. Basically what map does is it operates on every element of a series. And so here our series is this moves column, and we're going to apply a function to every element of that column. And the function we're applying is eval, because that's exactly what we want to do. And let's check out how quick that is. And what? No, that's not how things should be. Oh, I know why. Okay, it's because moves is a lot longer. Okay, that's a bad example. I'm sorry. Let's see what types. Oh. This, in theory, should be faster. If it isn't, okay, cool. It's faster. Nice. So this is about 4 times faster. And the reason is you're operating on one series instead of the entire data frame. So it's just really quick. And so if you have any kind of transformation that you want to apply to an entire column, I'd recommend map. If you want to some reason like do things with multiple elements, like for example, like you could, I don't know, concatenate multiple lists in the data frame, for example. In this case, you want to use apply because apply gives you access to the entire row at a time. Any questions about those three? Cool. The last one I'm going to show you is not faster, but it's pretty cool. It's this library called TQDM. This is just some boilerplate code that you have to run. TQDM is a super cool library. Essentially, it gives you like progress bars on what's going on. And so let me show you how that looks. Basically, all the basic functions, you basically add a progress underscore in front of it. And yeah, it's super cool. This is a super small data frame, but it gives you like a little progress bar. So if you have a little really complex function, you can see the progress of that function as you apply it to your data frame. And yeah, you can also use TQDM for for loops, by the way. It's like super cool. Check it out. Any questions about that? Cool. The last, or we're gonna do more things, but another thing we want to do is, it is kind of annoying to have to use like a number to access like an actual Pokemon. Ideally, we could just access it by the name, and so that's actually possible. And it's through a function called setIndex, and we basically pass in which column we want to be the index, and of course, as always, we want to do this in place. So let me actually, before I continue, the reason why like this in place thing is like helpful is because, for example, let's say you want to do multiple things, like, oh, you also want to drop the tier column, and you want to do like multiple things. It's like super convenient to construct something like this. So like you can chain these functions in a row, but when you use in place, you can't chain the functions. If you didn't get that, don't worry, that was just like a little side thing. But let's go back to the main one. Cool. So now if you look at this data frame, you'll see that the name is now the index. So basically, you can set the index to be any hashable type. In the backend, what happens is they use some sort of set data structure to quickly act as an index, exactly like a dictionary or a map, which gives you really fast access. You don't know what that means, don't worry, but it's quick. That's what's important. And so, for example, you could do stuff like Pikachu, and you will get Pikachu, which is super awesome. And I will show you another way to access elements right now, which is called ilock. And ilock actually lets you continue to use numbers. So it ignores the index and literally goes into the row of the data frame that you want. Cool. So any questions about that? Nice. I am going to skip something. Oh, yeah.
When you replace it per name, how would you, like, what if there's multiple rows of the same name?
Yeah, good question. So that's actually okay. What it'll do is, so right now it just returned a series with one row. If you have multiple rows with like the same index, it'll return like a little data frame with all the rows with that same index. So actually, I can show you. Oh, actually, I don't want to try doing that live, but I promise it'll do that. You can give it a shot. Any questions? Cool. Next thing we're going to do is create a column. You'll see that I type sample a lot. Like, even when I'm analyzing my own data, I'm constantly typing sample to look at the data frame because I have no idea what columns I have. I have no idea how anything looks. And so like I always type sample so I have like a row on the screen so I know what's going on. And the thing we're going to do now is create a new column. So in Pokemon, you'll know that there are these various stats. But if you're a Pokemon master, you'll know that a good way to compare Pokemon is to look at their base stat total. or in other words, the sum of like these 6 stats. And so let's create that column. And I'm going to cheat and copy and paste because I don't like to type all that stuff out. And so as you can see, we created this column here at the end, and this column ends up being like the sum of those 6 different things. So this is like, you can add data, you can add series of like the same length, and it'll add each of the elements. Any questions about that? Cool. We have 20 minutes-ish left, and so the last thing we're going to do is like some actual analysis. Ooh, spooky. Anomaly analysis. Cool. So most of this workshop has been like a mechanics workshop, kind of teaching you how to use pandas. And my hope is that after the workshop, you'll check out some of the links I gave you to check out how you can use these skills to do some analysis. I will show you one piece of analysis, and that's looking at anomalies. So let's suppose you're given this Pokemon dataset, and you want to understand the different tiers that Pokemon are in. So for some background, there's this world called competitive Pokemon, and there are various tiers in which these Pokemon can battle in. Stronger Pokemon are in higher tiers, and your task is to understand like what makes a Pokemon strong. Like, of course, there are obvious things like the stats that they have, but there are also less obvious things like the moves. And in my view, like the best way to understand something is, well, first look at the data, but also look at the anomalies. And this is super helpful for a lot of reasons. First of all, like anomalies are always very informative. The second thing is it can illuminate like data issues. So for example, if you see like a Pokemon that's in the wrong tier when you do this anomaly analysis, like that's great. You can go back and correct your data. And so we will do that. But first, you'll notice that, let's take a look at that column actually. Value counts. There are a ton of tiers. And actually, we don't care about all these tiers. And so I'm going to copy and paste more code because I'm still lazy. Oh no, I shouldn't have done this. So you can access columns using that dot notation as well. I will recommend you don't do that because there are some different properties to those accesses. Just use this. Cool. So basically what I'm doing here is I'm using the Boolean indexing, checking out which columns have this like tier that I don't want. I'm accessing the tier column, and essentially what I'm doing here is I'm promoting Pokemon in borderline tiers to the tier above. You don't have to understand the Pokemon part, but are there any questions about the pandas part that I just did? Cool. Oh, also, I noticed you're recording. I'm going to post the recorded thing later if you want to see it. So it'll be on the Data Science Club YouTube channel if this recording works out. Hopefully it does. So anyway, basically what I did here is, oh no, I don't want to launch Ubuntu. If you look at this tier column, we've already done this before. I basically moved, I promoted Pokemon in like borderline tiers to tiers above. And there's another piece of code I wanted to copy, but I didn't, so I guess I will have to type it out, unfortunately. Okay, I will have to actually do this in real life. So there's an is, so basically I want to get rid of these 2 tiers because I do not care about them. I just want to look at the other ones. And so you can actually do the following. Dot isIn limbo or AG. So what does this do? This basically is the isIn function basically checks if the value in this the element in the row is a part of this container. So this container contains 2 values. It just checks if it's there. So if we actually index back into the data set, we'll see that only these 3 Pokemon are in these weird tiers. And I don't want them there. So if we actually do a not here, oh, what's the not? There we go. Cool. So that little squiggly is the not in Python. So we want basically all the other rows except those ones. And we will reassign that to the data frame. Okay, cool. And so now, oops. Nope. Cool, we have all the tiers except the ones we didn't want. Yep. Oh, do you have a question? Oh, okay, I thought you were trying. Any questions about what I just did? Great, cool. So now we will actually start anomaly analysis, like I promised. And so I noticed that I told you that things that are like outside of the norm are kind of what we're interested in to understand what's going on. And so I told you about this base stat total attribute. And so this is like a very common way to assess how strong a Pokemon is. Like, you know, like if their base stat total is like over 600, they're considered like a very strong Pokemon, and like lower is like not very strong. And so basically what we're going to do is look at the average base stat total for each of the tiers and take a look at Pokemon that like deviate very far from those base stat totals and try to understand like why they deviate and if that gives us any information about what makes a Pokemon strong. So 2 notes here. First thing, we're able to do this analysis because we had some prior knowledge about our data. Super important. Like domain expertise is like the #1 asset you can have when doing data analysis. Which is why it's so important for non-data scientists, non-computer scientists to like understand data analysis and these techniques and like apply it to their own field. Like, because if you imagine like a Pokemon master with the tools of pandas, like would be unstoppable. But like a data scientist with no information, no knowledge about Pokemon, like may not be able to do so well. Anyway, we will look at aggregating some data now. So we want to calculate the mean base stat total across all the tiers, and I will show you how to do that. By the way, any questions about anything I said about prior knowledge or anything? Cool, great. So we can actually access multiple columns at once as follows. So basically what I did here is instead of just typing in one string here, I type in a list, and that basically lets me access multiple columns at once. And we're going to use something called a group by. Basically what a group by does is it literally groups by this tier. And so everything that has the tier PU, for example, it will put into one group. And you can see the output here is like a group by. And the reason is we need an aggregation. And so I will explain that. Aggregation. Cool. So what just happened here? What happened is we took the average base stat total by the tier type. And so we grouped by the tier, and our aggregation was a mean. And so that gave back one row per tier where the data we have is like the base stat total, which is like aggregated by an average. Any questions about that? Cool. So yeah, that's like typical group bys. This, you see this in pandas. This is available in anything you do, like whether you're using SQL, whether you're using like R for data frames. Like this is a very basic operation, and it's like super powerful as well. We also want the standard deviation, for example, and so we can do something like this. Oh no. Sorry, okay, ignore that. But np.std basically is a function that computes the standard deviation of a bunch of values. So really, aggregation should have should take in a function. It should be a function that basically takes in a bunch of values and reduces them to one value. I would highly recommend checking out the pandas documentation for this. The documentation is excellent. I'm just going to show you one example here. So I use a string here because pandas knows what mean is, but in reality, you can have any custom function you want that takes in a bunch of values and turns it into one value. Cool. As you can see here, there's a tiered column. So it's like BST has like 2 children kind of. I hate this. This is so annoying. Honestly, even today, I don't know how to access stuff in this data frame. And so what I do all the time is the following. Let me assign this, call this BST-df, base stat total data frame. And we will columns. Oh, no, I can't type. Like, see, it's just some weird multi-index thing. I honestly hate it. But so we can just rename this to the following: BST mean and BST standard deviation. And so now when we do BSTDF.sample, we don't have that weird multi-tiered thing, and we can just, oh no, what happened? That's not what I wanted. Oh, it's a sample. It's not the whole thing. Okay. Cool. So now we have normal columns just like we want. any questions about that, just don't deal with multi-index. It's so annoying. If you have to, I'm very sorry that you do, but you can check the Pandas data frame, the Pandas documentation to do so. Now, I mentioned that we want to identify Pokemon that are like very high or very low, have very high or very low base stat totals given the tier that they're in. And so somehow we want to join this information back to our original data frame. And so we'll look at something called a merge. And so joining is a very general concept. If you're familiar with SQL or any other kind of data frame libraries, you'll know that like is something you do all the time. Today, I'm going to show you something called a merge in Pandas. This is like the most generic type of join that's available, but it's not necessarily the most efficient. I encourage you to take a look at the documentation for there's a join function, and there are others that I can't remember, but merge is the easiest one to use, so we'll take a look at that. Cool. I'm going to reset the index. So before I continue, you'll notice that the index is now like this column here. Oh no, is it not? Oh, it's because I'm doing the wrong one. That's why. Cool. Actually, we don't care about that, but I will show you why I showed you that right now. If you look at df, we'll remember that the Pokemon name was the index. I am going to do something called reset index because I do not want that column to be an index anymore. And the reason why is there are some weird semantics when you deal with joining things with indices. Don't worry about it. Just in general, just reset the index and reset it afterward. It's much easier. So now let's do this join. So the function is called merge. And we're going to give the other data frame as the input. I'm going to type some stuff, and then I will explain what happened. I promise that. Oh, we want to reset this index too. Sorry. I will do this too. So here I'm doing the same thing. I'm resetting that index because I don't want that to be an index. And it's just easier to explain that way. Tier and how equals left. Cool. I will explain each of these pieces now. So the thing is, we want to append this information about the mean and the standard deviation to this data frame. And we want that information from the BST df. Left on means, so basically you need some way to join these data frames. They're not the same length, but you want some way to match up the columns. And the way we want to do that is match up by tier. And so we want to append, like, for example, any Pokemon that's a part of the NU tier, we want to append this information to. And so that's what we're specifying here, where the column in the left data frame, which is df, is called tier. The column in the right data frame, which is bstdf, is also called tier, conveniently enough. How equals left. I will not explain all the different kinds of joins today. I would encourage you to look into that. But left basically means that we're keeping all the values in this data frame no matter what matchings happen. Don't worry about those details. But if you look at this, what happened now is, cool, so Wismer is a part of this LC tier. And LC tier has like a mean of like 299. We appended that mean to this data frame, this new one called df2. I did a lot there. Are there any questions? Please raise your hand if there's questions, because this is like kind of weird. Great. Please feel free to come up to me afterward and ask me about this, because I'm happy to help. Now, the final part of our analysis, or, well, not the analysis, but actually getting the information for the analysis, is we want to take a look at Pokemon, as I mentioned before, that are kind of outside of the norm for their tiers. And so how can we do that? We will use Boolean indexing like we've been doing for a majority of this workshop, and see how we can do that. So this is what we want to do. We want to look at the Pokemon's BST, and we want to, let's say we want to look at Pokemon that are like under average for their tier. So what this basically means is that like their stats look super weak, but for some reason they're in this high tier. And so we can do that by checking that they're underneath base stat total mean. But we don't just care about the Pokemon that are under this mean, right? We want them to be a certain distance below this mean. And so actually what we're going to do is look 2 standard deviations below the mean. The reason why we're doing that is a mystery today because there are 5 minutes left. But there are good reasons to use that as the standard. And so just to summarize, this is going to return true whenever a Pokemon has a base stat total that's less than 2 standard deviations of the average of its tier. Those were a lot of words. Any questions? No? Okay, cool. And finally, we will index into our data frame as follows. And so now we have all these Pokemon that are seemingly weird that we can take a look at one by one because it's a small subset. And one thing that I found actually when looking at some of this data was, turns out a lot of these Pokemon have abilities that increase their stats. And so even though their stats seem low, there's some ability that helps them like boost their stats. For example, huge power doubles your attack. And so there we go, mystery solved for this Pokemon. Its stats don't actually reflect its strength. That is all the time we have for today. Just to recap briefly, we looked at pandas. We looked at accessing columns, manipulating columns, such as dropping and changing columns. We looked at the best way to modify data across your data frame by using the time it function in Colab / Jupyter, which are the same things. And we started to do a little bit of analysis looking at what are the anomalies in this data set and kind of understanding why Pokemon are in the tiers they are. And before they kick me out, here are the links once again. The workshop repo is this link right here. The full example of using some of these techniques to do an analysis is in that link right there. And yeah, feel free to email me, tweet at me. I'll be a mentor like all day tomorrow, so hunt me down and find me if you have any questions. Also, last thing, I have a workshop tomorrow at 12 p.m. Intro to Scikit-Learn. It builds on the knowledge that you learned here, so please come out. And yeah, thanks for listening. We can talk outside if you have questions.